Okay, for my internship this semester, I was working for Spectrum Engineers. They're an electrical building consulting company. The majority of my work this past semester focused on the Utah Valley Regional Medical Center Replacement Hospital. And within that, the majority of my responsibility fell under designing the electrical systems to support the kitchen equipment, as well as the nurse call system throughout the whole hospital. The hospital consists of about 2 floors of actual hospital building and 10 floors of patient towers, roughly. The extent to which I was in charge of, I was responsible for doing many different things, varying tasks here and there, laying out devices, determining where devices should be located, as well as doing device circuiting, do various parts in various different short circuit studies, coordination studies, arc flash studies, those types of things that were also involved with this project. But like I said, my main focus, my main area of responsibility for this project was with the kitchen equipment and the nurse call system. So here you can see this is half the kitchen that I worked on designing. This mainly is the servery area and the where you have people come in this way and are able to pick the food that they want. And there's some cash registers up here that they're able to check out at. But you can see here we have all the electrical service, for example, in this area for various types of equipment. They've got different hot and cold wells, stoves, grills, things like that, all in these various areas that need electrical power, varying electrical services to them. And then part of what I did was determining those requirements and then making sure that we provided the correct requirements and that it was correct according to the National Electric Code. And then here you can see this is the other half of the kitchen. This is more so the kitchen side of things, where they're doing the cooking and the baking. Where you can see they have various refrigeration units, as well as stoves, mixers, large mixers, things of that nature, and they're able to cook the food and then have it ready to go for the other area that we saw previously. Same kind of thing. We just need to lay out where the electrical devices need to go for these equipment connections, so that we can provide the proper electrical service to them. Another big part of this was this kitchen equipment schedule. If we zoom in here, you can kind of get an idea of what was put together here. So here we have basically a list of every piece of kitchen equipment that needed power. The equipment number for reference, we have an equipment description, the kind of connection type, basically whether it's just going to be a plug and a cord or it's a hardwired connection. And then based on the specifications of the equipment, what kind of receptacle was needed for powering that equipment, whether none was needed if it was a hardwired connection, or depending on what voltage and the amperage of the equipment, what type of receptacle of NEMA receptacle was required for that type of equipment. Here you can see we have the voltage, phase, and then the power draw for each pieces of equipment. And then here's probably kind of the important part here, is where we're specifying the wire size to be able to feed power to that equipment, to make sure that we specify the correct wire size for the amperage that the equipment's going to be drawing, so we don't overheat the wire, and that we're within the requirements of the National Electrical Code there as well. The other main portion of the project that I was responsible for was the nurse call system. So here, this is just for part of the nurse call system on the first floor, excuse me. You can see here how we run a PoE switch, power over Ethernet switch, that's able to communicate with all these devices. And we have various hubs and things that connect And it was my job to go through and design this, make sure that things are going to show how things are connected so they get connected properly in construction, as well as make sure that these runs of Ethernet have the power needed in order to supply power to all of these devices. You can see here for this run, we had to do a power injection here. However, it's set up so that all the data still flows backwards through to back to this PoE. But that was done. You can see the first floor took up about 3 sheets here. You can see it's fairly large. And then here is just a typical floor plan for the nurse call. Again, this is just a small fraction of what was done. You can zoom in on a couple rooms here. You can see what was required. We have what's called some staff terminals here, which allow the staff to interact with other staff to mark the room as being attended to or whatever's needed. And then we also have some emergency nurse call buttons here. Some staff. This is a combination button, a staff emergency or a code blue button, and then there's the patient station. That's pretty standard for the rooms. And here you can see the dome lights. There's a master station, things like that. So I was also in charge of, again, of laying out all these devices to show their exact location, not only in this floor plan, but this is also done in 3D modeling software. So we also have to make sure that these are in at the correct elevation as well. And that's basically it. You can see here as well that it's all wired up, and it's wired up pretty much the same as it was shown on the riser diagram as well. So those were my main areas of focus this semester. Like I said, there were other some random jobs here and there, things that I needed to take care of, but those were the big aspects and the majority of what I did this semester.